Okay everyone, so in this video I'm going to show you how to export from Revit so you can get into the MakerBot, and also the same export that I show you here is what's going to be used to get into the software that does wind analysis. So what I use is an STL exporter, and it's an add-in that you have to download into Revit. I show you where to download it in tutorial 8.1. If you haven't done that, basically just go to Google, type in STL exporter for Revit, and it's going to be the first hit. You just download it and install, and then the next time you open Revit, you go to the add-ins tab, and that's where the STL exporter is. Now, whatever's in your 3D window is what's going to export. So like even like if I had furniture and stuff inside this building, that's still gonna export. Since I created just this mask to kind of represent a kiosk. The size of the kiosk is actually 8 by 10 and then 12 feet high. You're actually gonna see when I scale this in the MakerBot that it's not, obviously a one-shot print won't fit, so that's why it's kind of good that you guys are doing this in parts anyway, to show how it goes together, because obviously it wouldn't fit as one big print. But since I'm going to just print this, I'm going to click it on the object that I want, and I'm going to hit isolate element. So just that exports. And then I'm going to hit STL exporter. But you will notice, so the first thing you see the two kind of tabs here. So if I click over categories, you see every single type of family that's in Revit is here. Even the imported DWG that I did for the site. And so what you can do is, if you have a building, like a full building design in the schematic design phase, and you have like furniture stuff on the inside that you don't want to export, obviously trying to like click it and hide it is a pain. Then what I did there, since it was just an easy cube. So in that case, you could come down to furniture and just uncheck it, and then furniture would be hidden. And when it export, since I was able, I don't have to worry about that tab since I was just able to do that. The difference between binary and ASCII is binary is more compressed, so you always want to pick that option. Obviously, with just like a cube, it's not a big difference. This is more when you kind of like export and everything. Include links models would be important. Probably when we start to get to the main building, and if you follow kind of like how I showed you the link Revit files back in tutorial B as part of the site. If you do like a site file and a building file and link the two, when you're exporting your building to say do like a wind analysis, it's always a good idea to have the site on there as well, so you can see, because the buildings surrounding your site may affect the wind direction or what blocks wind from coming. So that's why you would want to pick include all linked models if you ever link some another file to it, and then the rest I usually never check, and I usually leave it as feet for units, and then you just hit save. You see I already saved it as kiosk before, but I'll just save it as kiosk again and replace it. Now if you have, I have the MakerBot software on my computer. Where is it? There it is. If you don't have it, everything is in the computer lab. If you needed it, if you want to put it on the computer, it's free to do. Just go to Google and do MakerBot desktop software. Again, first hit for this one. It's free to download and install on your computer. It will ask you to create an account to sign in, and even when you actually first time you launch the MakerBot desktop app, it'll ask you to sign in. Once you're in the MakerBot, you go to the Repair tab. If you're not there, and this is what gives you to this screen. The first thing you want to do is you want to go to the devices and actually select the device that you're using, and then print an auto, because this changes the actual size you can see of the platform. I believe, and don't hold me to this, because I forget what actual devices we use. But I believe we use between a 2 and a 2x The maker bots that are in the computer lab that's above the wood shop is one type, and then the maker bots that are in the computer lab above the library is another type. And I believe it's a 2, and they're both, one's a 2x and one's a 2. I'm not 100% sure. I would just double check that. And I know there's kind of in last semester there was like a thing that you had to sign up for and even do a tutorial online through Professor Park before you can actually use the MakerBots. So I would just look into that to see if that's still the case. I know the TA for Professor Troutman's class. His name is Frank Chen, and he is actually more familiar with the whole MakerBot process through Professor Park and like the new sign-up process and everything like that. So we'll try to seek him out and ask him, kind of what should be done or what can be done. And he's actually used the MakerBots a lot, so he's good with these if you ever have questions on this as well. But it's a pretty straightforward to do. I'm going to select. I'm actually going to select 2 for the MakerBot 2 for now. And then when you want to add your file, just hit Add File. So you can see the supported types. If you're in SketchUp, you can actually export from SketchUp as an object file. So if you created anything in SketchUp, you can come right into the MakerBot from SketchUp. But we're obviously a binary STL, but I'm just going to leave it as well supported so I can see my file. And I bring it in. Obviously, it doesn't come in at the correct scale when you import. So I'm going to kind of drag it to the center. What I'm going to do is I'm actually going to scale it, show you how to scale it to the actual size for whatever scale that you have. But it's not. You'll see that it's not going to fit, and then I'm going to scale back down to just like a random thing to show you the rest of the kind of the steps quickly. But as you recall, I made this in Revit to have a 12-foot height, and I believe the scale that you guys are going to be printing out as is 1 inch equals 12 inches, or 1 inch equals a foot. So obviously, 12 feet is 12 inches in that scale. You can see this is in millimeters. I tried doing inches to millimeters before, but it never really works. So usually what I do, you can see how it has and I did an 8 by 10 and then a 12, a 12-foot height. So it's in there, but it comes in as millimeters. So basically what I just do is I just do 12 inches. I go Google and just do 12 inches to millimeters. Obviously you just times 12 by 25.4, but it ends up being 304.8. And if you leave uniform scale unchecked, if you put it in the dimension in 1, it'll scale the rest automatically for you. But you can see here, obviously it's way too big for what the MakerBot does. So again, that's why it's good that you guys are doing this in parts anyway, because it wouldn't fit even printed out full size. But I'm just going to scale it down so it fits, so I can show you the rest of the steps. So if you click on, after you do that, if you click on settings, this is kind of gives you what's going to print. A raft it kind of creates like a base for your whatever object that you're printing, so it kind of helps it stand up. So you can leave that checked if you want. Support. What support does, if you ever have like an overhang somewhere, say like I had a roof overhang like this, it'll create little thin supports to help it stand up while it's printing, and then they break away after you're done printing. And it's the same with the raft. Once you're done printing, the raft should be able to break away. Sometimes it's a little tricky to break it off. It depends how it is. Kind of like how big the raft is compared to the object and stuff like that. Obviously, you can turn the raft off if you want, but sometimes this will warp, so it's kind of like a hit or miss thing that you can do. Infill is, so basically this is a solid cube, and infill is how much of that cube is going to get filled. Obviously if it's 10%, only like 10% will that be filled, and the rest will be hollow. Layer height, so when this prints, it goes around and around and prints so many layers. So obviously if I have a 0.2 millimeters, It goes around once, goes up 0.2 millimeters, goes around again, and does it until it reaches the full height. Number of shells, that's how many times it goes around on the on each layer. So you can see here, if I have 5 shells, it'll go around once, move in a little bit, go around again, move in a little, go around again, until it reaches 5, then go up 0.2 millimeters and go around again. Obviously, I'd probably like between like 2 or 3 or something like that is probably good enough. And it's again something that you can test. You can see the quality. They have stuff between low and high that kind of has already settings. You can see high, it changed to 0.2 layer height. Standard is high was 0.1, standard was 0.2, and low was 0.3. If you click on custom, you can see those, and you can actually change this stuff. A little bit more detailed version of it. I usually just stick with standard. It's kind of like the best, and I usually leave this, always leave this the same as well. Again, this is something that I would check with, kind of like Professor Park's tutorial. They may have like a special material that they've used. I don't know if if he's bought a flexible filament material to be used. Typically, it's just kind of the PLA material. But again, that's something that you always want to double check. And as I mentioned, I believe there's a tutorial that people have to do online before they can use the MakerBots. I'm not 100% sure if that's still the case. I know it was last semester, so I'm assuming it is this semester. So once you have those settings up, you can actually do a preview, and it'll actually do it'll kind of preview your object, and you can see it's taking a little time, but it gives you a preview. It'll tell you how much material is being used, basically about how much time it'll actually do to print. So you can see this object alone would take like basically 5 hours to print. So you can zoom around. If you zoom in, you can kind of see what the raft is. So you can see there, you see how it's a little bit wider than my object. So you can see the raft. So you can see at a 0.2 millimeter layer height, there's going to be 436 layers. And you can actually lay down, you can scroll down to see what it looks like. And then you see, so that 10% that I had for fill, it does like an octagon shape to get that 10% fill. So that's what the fill does. So I'm going to show you settings. I'm going to just increase this to 4. And I'm going to do, let me do it 25% fill. Then OK. And then again, I'll do a preview, and it's going to run print preview again. And it brings it up, so you can see now with these settings, I only have 222 layers, and I've cut like an hour off of my print time. And then again, if I scroll down, you can see the fill, the hexagons got smaller because I asked for a bigger fill on the inside. So again, that kind of depends on how big whatever your object is, and how, if you want it hollow or if you want more of a solid fill. Obviously, if you went 100%, it would just be a big solid structure with all material, but that would probably take forever to print. So once you have that set up and you're good to go, you just I believe if you're on the computers in the lab that are hooked up to the MakerBots, you can just hit print and it'll print. If you're setting this up on your own laptop, probably best just to save this and then bring it back in on the MakerBot computers. I think that's probably the case that what you have to do. I know before you'd have to export the file, this type of file, and then hook it up, with an actual kind of like, one of those kind of micro disk. But I believe you can just print now from the program itself that are hooked up to the MakerBot printers from the computers. But that's it for this video.